Hello and welcome everyone, this is Noah, and in this video we're going to go through how to find the vertex and axis of symmetry for a parabola given a quadratic function. So we've got this example to start us off. It says, given the following functions, determine the vertex and axis of symmetry. So let's just remind ourselves, if I had a graph, I'll just sketch it in here. We're not looking for anything too detailed at the moment, just reminding ourselves what it is. Say we've got a parabola drawn, and then we have a turning point, right? Either a highest point or a lowest point, and we call that point the vertex. This point is always going to have an x value that is the axis of symmetry. So this is the axis of symmetry. And that x value is always going to be halfway between the x-intercepts. So we're going to start by just coming up with a formula for that axis of symmetry. And to do that, I want to start by just giving it to you. So the x value for the axis of symmetry, so that abbreviation is for axis of symmetry, is going to equal negative b over 2a. Which is really not a hard formula to enact, and we're actually going to find some other ways for proving where this formula comes from later on and finding other ways of getting it, but we're going to save that for a couple of weeks from now. Right now we just want to use this formula. I do want to give you one proof of where this formula comes from. I said here that it's the halfway point between the x-intercepts. So here we have the first x-intercept and the second x-intercept. If we remember the quadratic formula, the x-intercepts can be given by negative b plus or minus the square root of b squared minus 4ac all over 2a. And this is given a function f of x, or let's call it q of x for quadratic function, equaling ax squared plus bx plus c. So with the plus or minus, we get the two different x-intercepts. We have x1 is the positive, negative b plus the square root of b squared minus 4ac and all over 2a. And then x2 equals negative b minus the square root of b squared minus 4ac all over 2a. If we take the average of these, if we go x1 plus x2 divided by 2, that's going to give us the x value of the axis of symmetry. And if we compute this, if we add the x1 and x2 together, I'll have negative b plus the square root of b squared minus 4ac all over 2a plus negative b minus the square root of b squared minus 4ac all over 2a, and then all of that would get divided by 2. So when we go to simplify this, we end up having a plus and minus of this square root that cancel. So we get negative 2b over 2a, because they have a common denominator already, and then all of that divided by 2. So we can go through and simplify this. On top, the 2's cancel, and we get negative b over a, all divided by, we get a negative b over a divided by 2. And this 2 is over 1, so we could say negative b over a times 1 over 2, flip and multiply that bottom, and that'll give us the negative b over 2a value. Okay, now you guys don't need to reprove that ever. All you need to do is be able to use the formula, but I want to show you that it's not a magical formula. It has a place where it comes from that's meaningful, and so that we know that this formula is always going to work for us. We'll also end up proving the quadratic formula by the end of this module, which will be nice to see that that's not a magic formula either. All right, so let's take a look at using it. So for problem 1, we can say that the x value for the axis of symmetry is going to equal negative, and then the b value is -2. We want to keep in mind that negative there. And the a value we need, the a value is implied to be a 1. I don't have 0x squareds there, I have 1x squared. So a is 1. So if we plug this in, we'll get -2 over 2 times 1. The negatives will cancel, and 2 divided by 2 is 1. So the axis of symmetry is x equals 1. We can just abbreviate this. The x value of the axis of symmetry equals 1. To find the vertex, all we need to do is take that x value and plug it into the function. That'll give us 1 squared minus 2 times 1 minus 15. And simplify this down, so I get 1 minus 2 minus 15. And 1 minus 2 is -1, minus 15 is -16. So the vertex is at 1, -16. We know that we can just plug that x value of the axis of symmetry into the function to get the vertex, because we know the vertex is on that axis of symmetry. I know that if I plug that x value in, I'll get this point on the graph. So that's why we just plug that in there. So our answers for this first problem are the x value of the axis of symmetry equals 1, the vertex equals 1, -16. All right, so let's do this a little bit faster for part B. All we're going to do here is say that the x value of the axis of symmetry equals negative b. B is 12. Let me actually bring this down. B equals +12, and a equals -2. So those are the two numbers we need for our formula. So I have negative, and then b is 12 over 2 times a is -2. Right, it's negative b over 2 times a that we're using. And so the negatives cancel, and we get 12 over 4. 12 over 4 is 3. So the x value of the axis of symmetry is 3. We'll then take this and plug it back into the function to find the vertex. G of 3 equals -2 times 3 squared plus 12 times 3 minus 10. We'll simplify this down. We get -2 times 9 plus 12 times 3 is 36, and then bring down the minus 10. So it'll be -18 plus 36 minus 10. And -18 plus 36 is +18. Bring down the minus 10, and that equals 8. So that tells us the y value of the vertex. So the vertex here equals the point 3, 8. I'm going to go ahead and just clean this up a little bit, move that out of the way. Show everything, all of the work here. Let's take all of this, and we're just going to shrink it down a hair so that it's not so imposing, but still readable. All right. Cool. All right, that's everything here. It's really not that bad once you get used to it. It's just being able to apply that formula and then plug that x value back in to find that vertex, find the y value of the vertex, and then state it. All right, go ahead and go into the mind map and look at the Now You Try problems and give those a shot. And in the next video, I will walk through those solutions. Thank you very much. We'll see you soon.